Okay, here's a solution for 2010 Form B number 5. Let's see, part A. Given this g function here, we want to find the maximum value on the open interval if the maximum exists, and the minimum value if that exists, and to justify our answers. So to find maximums and minimums, I'm going to find the derivative of that function I'm interested in, and that would be low d high minus high d low all over low low, and that's going to be equal to 0 wherever the top is equal to 0. And notice here that the bottom is always positive because it's something, actually in fact this is always positive and then it's getting squared again, so it's really positive. Simplifying the top, that would give us 4 minus 16x squared. Sorry, I wanted to write this. So g prime of x equals 0 when 4 minus 16x squared is equal to 0. And that happens at x equals plus or minus 1/2. But we're only interested in 0 to infinity. So I'm just going to make that open so I know that we're not counting 0 as part of our interval, right? It's open from 0. So if I plug in some values into this, you should find that, in fact, right, you can try plugging in 0 and then plugging in something above 1/2, and you will find this. So that is g of x has an absolute max. It's absolute because this is increasing and decreasing. It's the only maximum. That's the only sign change of the derivative. It has an absolute max at x equals 1/2 because g prime of x has only one sign change. And they asked, like, what is the actual maximum value? So I got to plug 1/2 into there. So g of 1/2 is equal to 4 times 1/2 over 1 plus 4 times 1/2 squared. So that's 4 times 1/2 is 2. 1/2 squared, that's over 2 over 2, which is 1. Last time I checked. All right. Now we want to also look for minimums. Well, this is decreasing. The two candidates would be here and whatever. I mean, we're not. This isn't really a candidate, right? Because that's we're never getting to infinity. But let's look at what's happening here. We would have to check out that limit. So actually. No, we can't have a minimum because it's an open interval. So even if this did descend down to some lowest value, it's not a minimum because it's an open interval. You know, you'd get forever closer and closer, and you never get to that minimum value. No minimum because the interval is open. Okay? Part B. Find the area of the unbounded region in the first quadrant to the right of the vertical line x equals 1, below the graph of f, and above the graph of g. So they're basically setting up an integral for us there. They want us to find the area from 1 to infinity of f of x minus g of x. So let's take the antiderivative and see what we can do. Remember, with these improper ones, we're hoping that we can plug in infinity and get it somehow to resolve itself into an answer. And certainly I think we expect to get an answer here because it says find the area. It doesn't say find the area or state that it does not exist. So we should get a number here. At least that's what I'm thinking. All right, the antiderivative of this would be natural log x minus the antiderivative of this. Let's see, if we let u equal 1 plus 4x squared, du would be 8x, and that means I would need a 2 on the inside, and that means I would need a 1/2 on the outside. So that's going to be minus 1/2, and then that's going to turn into 1 over u. You should write out this in more detail if you need to. That's going to be the natural log of u, or in other words, the natural log of 1 plus 4x squared from 1 to infinity. And that's equal to the, well, I think, let's see. Let's put this together first before we plug this in, because if we don't, we're just going to get an infinity minus infinity, and that's just kind of nonsense. So I'm going to say here, using logarithm rules, if I bring this to the inside as a 1/2 and then use this minus to make it into division, then that turns into the natural log of x over the square root of 1 plus 4x squared from 1 to infinity. Right? And when I plug infinity into this, as x goes to infinity, this is actually same power over same power, right? Because the square root of x squared is just x. So that's like, you could think of this as like, that's like the square root of x squared, right? So same power, top and bottom. That means it's just the ratio of the coefficients, remembering it's under a square root sign. So I think we have a 1/2 in here, right? So that's going to be the natural log of 1/2. Because when I plug infinity in here again, that's like letting x go to infinity. It's the same as a limit. And that's same power top and bottom minus the natural log of, when I plug 1 in here, that's 1 over the square root of 5 right? And that's equivalent to the answer that they give, although it's not exactly the same. I'll let you check and see if you can see how it is the same. All right, that wasn't too bad. That was a little bit tricky once you get through here, but even you do get a couple of points, a good couple of points, just for setting up the integral and then finding the antiderivatives. So even if you got a little bit stuck through this end process here, you can definitely pick up some solid points.